Welcome everybody to Algebra 2, Section 1.4. Today we're covering compound inequalities and special cases. So let's define compound inequalities. Compound inequalities just means two or more inequalities that are graphed together on the same line. So we have two types of compound inequalities. We have or compound inequalities as well as and compound inequalities. And so type 1 are the or compound inequalities. Now when we think of or, when you're given two choices and it's this or that, you pick one of them typically, okay? In this case, we're gonna have both displayed still, but they're separate options. There's no overlap between those options. So for example, do you want to do this on Monday or Tuesday? And we're not saying both Monday and Tuesday, you're saying pick one between Monday and Tuesday, but both are displayed as options for you. So it's impossible to be both at the same time, Monday and Tuesday, but it can be one or the other for the days. So here we have these two inequalities that are graphed, and so we have this graphed on the left as well as this graphed on the right, and together they make the compound inequality. So as we write the inequality, we're going to write the one on the left here, and we're saying that x is less than or equal to negative 4. X is less than or equal to negative 4. And then we're going to put the word or in between, and now we're going to write down this inequality, which is x is greater than 1. And if we write it in interval notation, we write this from left to right. We're saying we go forever left, negative infinity, comma, we go right to negative 4, and the negative 4 would be a bracket, negative infinity would be parentheses, like we covered before in 1.3. Then we're going to put the other side over here. Now when we do interval notation, though, we have to put this little u that is very specifically without this tail that I overemphasized. It's a u without a tail, and that stands for union. It means we're doing this part on the left, union, and the part on the right. And so on the right there, we go starting at 1 on the left to infinity on the right. And so those would both be parentheses. So we're saying it exists on this interval as well as this interval. That union, and then the other part, which just means, once again, both pieced together. And then for set notation, we just write this inequality again. However, before that, we put the brace, the x, the such that line, and then we rewrite those two. X is less than negative 4, or x is greater than 1, and then end the brace again. And so for set notation, that's very similar to how we've done set notation previously in 1.3, where we just rewrite the inequality after that such that line in between the braces. So to solve these, when there are actual problems like we see here on like 1 and so on and so forth through number 6, we have to solve each part individually, then we graph it on a number line to show the solutions. So on number 1, we're going to treat these as two separate problems. So the first problem, we'll start with this. And we subtract 4 on each side to get 3x is less than or equal to 6. We divide 3 on each side to end up getting x is less than or equal to 2. Now we solve this other part as well. So we divide by 5 in the other inequality to get x is greater than 9. And so we have x is less than or equal to 2, or x is greater than 9. And these are the two inequalities with the word or between them. Now we're asked to graph and put it in interval notation. So when you graph them, you just graph them one at a time. So the inequality on the left, it's a circle at 2, and it's a closed circle because it's or equal to, going to the left because those are the numbers less than 2. And then for 9, it's an open circle at 9 going to the right because those are bigger than 9. And so or inequalities should be going outside opposite directions because they do not overlap with each other. If it were to have gone this way, notice they overlap when it gets to this point because 10 would be greater than both 2 and 9. So there's no overlap between or options, similar to how, once again, using that Monday or Tuesday example, there's no overlap between Monday and Tuesday. Here's Monday and here's Tuesday. And the interval notation, we would do it like we did up above, to where you go forever left, all the way to 2, and it stops at 2. And then it picks back up again over here at 9. And so we have union, that U without a tail, 9, comma, infinity, and those both have parentheses because 9 is an open circle. On to number 2. On number 2, we once again just solve these inequalities separately from each other, and then we graph them one at a time and write the interval notation. As I do with all these, I encourage you to pause the video, work on these problems, and then play the video to see how you did compared to me and get any help you might need at that point. So this first inequality here, I'm going to subtract 6, and n is less than or equal to -1. The second inequality, I'm going to subtract 7 and get 9n is greater than 36. Dividing by 9 on both sides gives me n is greater than 4. So we have n is less than or equal to -1, or n is greater than 4. So graphing those one at a time, -1 is a closed circle going to the left, 4 is an open circle going to the right. And just like I mentioned on number 1, they do go opposite directions, and that should happen when we do these OR inequalities. So the interval notation, it goes forever left. Then we have it going to -1 with a bracket because it is a closed circle, negative infinity is a parenthesis. And then we have the right part of the graph, so we put a union saying we have the left part and the right part. That'd be 4, comma, infinity, with the 4 being a parenthesis. On to number 3. Once again, solving these separately, so I'm going to subtract 8 from both sides of number 3 and get -3y is less than or equal to -15. Now I have to divide by -3 on both sides. And remember, when we divide or multiply both sides of an inequality by a negative, we have to flip our inequality symbol. So it's y is greater than or equal to 5. On the other one, I add the 3 and I get 10y is less than or equal to -30. Dividing by 10, we get y is less than or equal to -3. And so we have y is greater than or equal to 5, or y is less than or equal to -3. Now, some people are sticklers about putting the one with a smaller number first and the one with a bigger number on the right. I'm not going to be so terribly as a stickler on that. However, I do want that to be the case for interval notation. The one with the lower numbers will be on the left, and the one with the bigger numbers needs to be on the right for interval notation. But for this, I'm okay with it. When we go to graph, we graph them one at a time again. So let's just say I graph this one first this time because it's on the left. So I put a closed circle at 5, and greater than 5 goes to the right. Whereas y is less than or equal to -3, we will put that on -3 and go to the left because those are less than it. So once again, this does go opposite directions, and I'll do interval notation from left and then going to the right. So my left one, I go negative infinity, comma, -3, parentheses around negative infinity, and a bracket for -3, union, and now I do the second part of the graph, which was this inequality. So 5, comma, infinity, and 5 is a bracket. Number 4. We have to solve this first inequality again. So I'm going to subtract 6 and get -2a is less than 2. Divide by -2 gives us a is less than, change the inequality because we divided both sides by a negative. A is greater than -1. On the right hand side, I'm going to subtract 1 and get a over 2 is less than -3. Then I'm going to multiply both sides by 2 or 2 over 1. I get a is less than or equal to -6. And so the a is greater than -1, or a is less than or equal to -6. And once again, some people are going to require you to put this on the left and this on the right when you write that out in that line, because the one on the smaller would go on the left. But once again, I'm not going to be nitpicky about that, just on the interval notation. So when we go to graph, I graph the -1 part. The first inequality I've written there, I put an open circle at -1 and I go to the right. And then when I graph the second inequality here, I'm going to put a closed circle on -6 and go to the left. And that's just following what we see there. So now interval notation, negative infinity, comma, -6, with -6 having a bracket, union, the right-hand part now, after we do the left-hand part, is -1, comma, infinity, with both parentheses. On number 5, these just get more and more complex as we continue going, so I can either distribute the 3 or I can divide both sides by 3, which is what I'm going to do to save myself some bigger numbers. So 5 minus 2k is less than negative 4. If you distribute that 3 instead in that step, you will still be able to get the right answer. Your numbers just look bigger in the meantime, but by the time we get to the end, they're the exact same. So if I subtract 5 from both sides, I get negative 2k is less than negative 9. And dividing by negative 2 makes me flip my inequality to have a greater than instead of less than, and it ends up being 9 over 2 or 4.5. If you put 9 over 2 or 4.5, that is also okay. I'm going to put 4.5 here because I find it easier to graph when I see the decimal. On the right inequality here, I need to get rid of this 1/3. I can either distribute the 1/3 or I can multiply by its reciprocal. You pick. So let's say I choose to, multiply by the reciprocal here, okay? So I multiply by 3 over 1, and those reduce, and we end up getting 15k minus 9 is less than or equal to negative 9. I add 9 to both sides, and I get 15k is less than or equal to 0. I divide by 15, treating 0 as any other number, and get k is less than or equal to 0. So now it's this or that for my final answer. Once again, I'm not going to require a certain one to be on the left or the right when we write those inequalities. So graphing this one, k is greater than 4.5. I'm going to go halfway between 4 and 5, and then you need an open circle there going to the right. Graphing k is less than or equal to 0, closed circle at 0 going to the left. And the interval notation would look as the following: negative infinity comma 0, with 0 having a bracket, negative infinity having a parenthesis. I made my 0 there really small. And the u for the union, once again, no tail, and 4.5 comma infinity. And here we have the parentheses on both of those. I do want to go ahead and just show what it would have been like on this problem here had I not multiplied by the reciprocal and instead distributed. So just to showcase that there briefly, if I distributed here of this 1/3, it's 1/3 times 15k, which you can think as 1/3 of 15k, and 1/3 of 15 is 5. AKA you put this over 1 and you cross reduce. Maybe you do that off to the side, like 1/3 times 15k, 15k over 1, and you cross reduce those to 1 and 5. So we get 5k. And same thing, 1/3 times negative 9 is as if we're just dividing by 3 again and getting negative 3. It's less than or equal to negative 3. So here our numbers actually ended up smaller because we multiplied by this fraction where it was 1 over a number. And so as I add 3 to both sides, I still just get 5k is less than or equal to 0. And dividing by 5 yields the exact same results as before, where we get k is less than or equal to 0. Number 6 here, I have to deal with this negative 3 first because the entire part's being divided. If you tried to get rid of this 8 first, you would have an issue because this is secretly this. And so if you try to move this 8, you actually have to add 8/3 rather than just adding or subtracting 8, and that gets messy with fractions. So I'd encourage you to avoid that by getting rid of the fraction by doing multiplication of negative 3, the same number, over 1. Negative 3 and negative 3 reduce, and you're left with 8 minus x. Multiply the other side by negative 3. We flip the inequality since we multiplied both sides by a negative, and it's 15 on the right. Now 8 minus x is greater than or equal to 15. I subtract 8, and I get negative x. That negative stays with the x, is greater than or equal to 7. I would divide or multiply by negative 1. It's the same exact thing because this is secretly a negative 1x. So whether you divide both sides by negative 1 or multiply by both sides by negative 1, it's just a preference. Either way, we do need to flip the inequality since we're dividing or multiplying by a negative on both sides, and we get x is less than or equal to negative 7. On the other part, we subtract 5 first, and we have negative 3 over 2x is less than negative 6. I will now multiply by the reciprocal to undo this fraction, and that would be 2 over negative 3. and we get x on the left. And since I multiplied both sides by a negative, I flip the sign, and I'm going to reduce negative 6 and 3 by 3 to become 2 and 1. So I multiply 2 times 2 straight across, and I get 4. On the bottom, 1 times 1 is 1, so I could put over 1 if I want, or I can just leave it. So x is less than or equal to negative 7, or x is greater than 4. And so as I go to graph these, I put a closed circle at negative 7, and to the left, an open circle at 4, and to the right. Interval notation would be negative infinity comma negative 7 with a bracket on negative 7. Union, or that u, my infinity didn't turn out well, but union, that u, we use the right part, so 4 comma infinity. That was worse. Let me try again. There we go, with parentheses around both. And so now we're going to go on to the next page talking about and inequalities. And think about it this way, Monday and Tuesday, you're doing both. Okay, so it's the overlap between the two. It's both Monday and Tuesday rather than two separate options, Monday or Tuesday, okay? Or you can think of it as I'm going to have chocolate milk and dairy today because they're the same thing. Chocolate milk is a type of dairy, okay? Or you can say I'm going to have milk and chocolate today, and the way you do that is by having chocolate milk by chance. So and here, we see this graph where they connect in the middle. We don't see any arrows because it just exists between two numbers, including negative 2 in this case. So the inequality looks different, okay? So how we write our inequality is going to be x is greater than or equal to negative 2. That's this part of it, right? We're greater than or equal to negative 2. And x is less than 5. So both are true. We're greater than or equal to negative 2 and at the same time being less than 5. So notice we didn't put over here, even though those are also greater than negative 2, because they're not less than 5. And we're saying that it has to be both greater than negative 2 or equal to negative 2, as well as less than 5 at the same exact time. Interval notation from left to right, we do negative 2 on the left and 5 on the right because it's between those two. A negative 2 would get a bracket where 5 would be a parenthesis because it's an open circle. Set notation, I'm actually going to cover that in just 1 second after I show here what we're going to do down here. So rewriting and inequalities. So because the solutions to an and inequality fall between two endpoints, like we see here up on the graph, they are frequently written in a more condensed form. And this is the form I'm going to want you to write these in. Okay, I'm going to require you to write them in. So the example up above is that x is greater than negative 2, greater than or equal to negative 2, and x is less than 5. So that's the same example we have right up here, okay? Now, what I want you to do is write it like this. Essentially what happens there is we take the smaller of the two numbers, in this case negative 2, and you write that first. You take this symbol, but we need to flip it, because here we're saying x is bigger. So we have to keep x bigger as we flip the symbol. Then you write your variable x. Then you write your symbol over here for your bigger number, less than, or if it was less than or equal to, you put the or equal to, and then the bigger number, 5. And the reason why we write this as a condensed form is 1, it's less writing, but 2, it's a visual that x is between 2 and 5. Our solution is between those two endpoints. And so here we have number on the left, number on the right, and x is in the middle of them. It's bigger than the one on the left, it's smaller than the one on the right. And I lost my negative there at one point. It's bigger than the one on the left, it's smaller than one on the right. And so these are always going to be less than symbols as we read them, or less than or equal to symbols depending on the specific problem. So when we do set notation, instead of doing our x such that with our braces and rewriting this up here, we're rewriting our condensed form of -2 is less than or equal to x, which is less than 5. And I do, in fact, want the condensed form in these. And that's how I want your answers written. So now let's work on solving it, okay? So solving it, we have two different scenarios. One where the word and is written out, okay? So that'd be like numbers 7 and 8, and the other where they're condensed, which would be like 9 through 12, where we see two inequalities but only one instance of the variable between them, perhaps, okay? And it is possible you can have multiple instances of the variable meant to move things around, but it won't typically be that way, and we won't see that in this class. So we're supposed to solve, graph, and write each solution in interval notation. So same instructions as before. So when they're and inequalities, we solve them separately. So the number 7, solving the first inequality here, I'm going to subtract 3 from both sides and get 2x is greater than -12. Then I'm going to divide by 2 on both sides and get x is greater than -6. Then I solve my other inequality by adding 2 and get 8x is less than 32. And dividing by 8 results with x being less than 4. Now I will rewrite this as my condensed version. So I write the lower number between -6 and 4, that's -6. I put this symbol but flip it. It's always going to be less than or equal to. It's not or equal to here, so it's not or equal to here. Then I put x, then I put this part less than 4. If it was or equal to, we'd put or equal to. So smaller number, x, bigger number, was either less than or equal to symbols between them. And that would be our answer. And now I graph it, and so I do an open circle at -6, an open circle at 4, and I connect those dots. The interval notation would be, like we talked about above, -6, 4, where it starts to where it ends, and in this case, they're both parentheses. Number 8. We're going to solve these again. So solving this first one by subtracting 1, we start with 2w is less than or equal to 10. Dividing by 2 results with w being less than or equal to 5. On the second inequality on this problem, we subtract 1 to get -5w is less than 40. Then dividing by -5, w is greater than -8. And so to rewrite this, we start by doing the smaller number, which is -8 in this case. We flip this inequality and make it less than the variable. And now we do the same inequality, less than or equal to 5. Once again, you'll notice that these are always going to be less than symbols or less than or equal to symbols. So now I put -8 as an open circle, I put 5 as a closed circle, and I connect the two. The interval notation would be -8, -8, 5, where -8 is a parenthesis and 5 is the bracket. So it's a case-by-case basis, whether it's a parenthesis or a bracket or parenthesis, depending on the symbol being open or closed or equal to or not. So now on number 9, when you have these condensed versions of these and inequalities, how we solve it is a little bit unique compared to before. So before, when we would subtract 3, we'd subtract 3 on both sides of the equal sign. And when we divide 2, we divide it on both sides of the equal sign. Okay? Here, there's multiple sides. There's really 3 parts. There's a left, there's a middle, and a right. So whatever you do to one part, you do to all 3 parts. So similar to having to do it to every side, which was before just both or 2, here we do it to all 3 parts. And so A is being subtracted by 1, and so I add 1. And if I add 1 in the middle, I add 1 to both sides as well, on the left and the right. So I add 1 to all 3 parts, resulting in -1 is less than or equal to A, which is less than or equal to 7. And now my A is by itself, so I solved it. And it's already written in the condensed form, which is nice that we don't have to rewrite it that way. And so I'm going to put a closed circle at -1, a closed circle at 7, and connect the two. And it'll be -1, 7, and they'll both be brackets since they're both or equal to and closed circles. Number 10. Here we have a little bit more going on in the middle. It doesn't change how we approach it. So we still say, okay, if this was not there, we'd still subtract the 4 first. So we just subtract 4 from all 3 parts. Writing it out here might be more beneficial for us at this point. 0 is less than 3p, which is less than 15. Then we divide the middle by p to get rid of, or by 3, excuse me, not by p, to get p by itself. But if I divide one part by 3, I divide all 3 parts by that as well. And 0 divided by 3 is 0, and 15 divided by 3 is 5. And now we have 0 is less than p, which is less than 5. And that's our answer. So graphing it, we do an open circle at 0, an open circle at 5, and we connect the two. Interval notation, 0, 5, and we have parentheses on those. Moving on to number 11, we're going to be continuing to do the same thing. Now notice here, these are greater than symbols. That's odd. Let's work through the problem, and I think we'll realize why that's the case on this problem. So I have to start by adding 2 on all 3 parts here. I almost said both, but all 3 parts here. And we get 30 is greater than negative 10m is greater than or equal to negative 5. Now I need to divide all 3 parts by negative 10. And I get 3, I get m, and I get 1/2, or I'll just call it 0.5. But because we divided everything by a positive or a negative, we must flip the inequality. So I have to flip both inequalities here. And now, as we look at this problem, my apologies, it should be a negative 3 on the left. Now, as we look at this problem, we notice it does go lower number on the left, bigger number on the right, and they are less than or equal to symbols. And so the reason it was flipped around before is because as the problem was made, the author said, hey, I'm going to put the greater than symbols so that way it ends up the correct way without any further modification. If we did not have it the correct way before, so for example, if the whole thing was flipped around, you had negative 7 is less than or equal to negative 2 minus 10m, which is less than 28, and we were to go through solving this, we do all the same steps of adding 2 everywhere, just like we did before, and we get all the same numbers, just flipped around on which side, and we get so on and so forth, like this. And then as we divide by 10, or negative 10 rather, I lost my m in the blue there. I get m, I get negative 3, I get 0.5 again, and then I flip my inequalities, and now I notice that it's not written in the correct manner. It's written where it's bigger number on the left, smaller number on the right. These are greater than symbols, and so now I have to flip it around. So I put negative 3 on the left, I put 0.5 on the right, and just like any time we flip around the inequality, we have to flip our signs as well. Although I realize that my negative 3 should not be an or equal to, but I wrote or equal to, so I have to fix that. My negative 3 was not or equal to before. And that'd be less than or equal to 0.5. So we end up with the exact same answers, but we had to do an extra step of flipping it around because the author didn't flip it around, me in this case, to show you what would happen there, okay? So now as we graph this, I'm going to put negative 3 with an open circle, 0.5, which is halfway between 0 and 1, with a closed circle, and connect the two. Going to put negative 3, comma, 0.5, or 1/2, and negative 3 has a parenthesis, and 0.5 has a bracket. Moving on to number 12. I said negative 12. So here we have this negative 2 that everything's being divided by in the middle. So we have to undo that by multiplying by negative 2, or negative 2 to 1 over 1, and we do it to all 3 parts. And as we do that, in the middle, negative 2 and negative 2 reduce, and you just get left with 12 minus x. On the left, negative 2 times negative 5 gives us 10, and on the right, negative 2 times negative 2 is 4, but because we multiplied every single side by a negative, we have to flip our symbols. Now, we have to subtract 12 from each side. So I subtract 12 from all 3 parts, and I get negative 2 is greater than or equal to negative x, which is greater than negative 8. One more step to get this negative away from the x, I have to multiply or divide everything by negative 1. And I get x, I get 2, I get 8, and I flip my inequalities once again because I'm I'm dividing everything by a negative, or if you multiplied, same idea. And now I have my lower number on my left, my bigger number on my right, and they're both less than or equal to symbols. And everything worked out just fine on this problem at the end, naturally, rather than us having to move things around like we thought we might have when we saw this. So now graphing it, we have 2 for a closed circle, 8 for an open, and we connect the 2. And we have 2 comma 8, with 2 being a bracket and 8 being a parentheses. Moving on to the next page, we're going to talk about special cases or unique scenarios. So special cases, we previously learned that compound inequalities are 2 inequalities joined by the word or and. Now we will be looking at special cases in which there's no solution, infinitely many solutions, or what we call overlapping solutions, okay? Now an example for, let's say you're going to the zoo. I love going to the zoo with my son. So a sign at the ticket booth reads, guests that are under 3 years old and over 62 years old get free admission. And the question is, does that make sense? If not, why? And how would you change it? So when we see the word and there, like I mentioned before, it means both are true. So is any one guest going to be both under 3 and over 62 years old? No, it's physically possible to be both at the same time. Rather, they mean guests that are under 3 years old or over 62 years old get free admission. So they don't really mean that you can't be that you have to be both. They mean one or the other. And that might seem pretty nitpicky, and it is to be fair, but it's to drive the point home during this lesson. So I'm going to write no, that doesn't make sense. And why, I'm going to put you can't be under 3, and I'm putting in all caps to emphasize, over 62 years old at the same time. So how would I change it? I will say it should say or instead of and. Guests that are under 3 years old or over 62 years old get free admission. So that way both groups of clientele, the young and the old, can get in for free. Now, we have a lot of different examples here that we don't have to solve, thankfully, because they're already solved for us. It's just the variable compared to a number. But we are going to graph and put it in interval notation. Now, as we go through these special cases, I encourage the use of a rough draft. Similar to when you write a paper in English and you're writing a rough draft, it's going to have some errors. It's going to be fixed. It doesn't have to be perfect, okay? It's kind of the working space. And then you put your finished product in the final draft. So we're going to put our finished product on the graph, but we're going to put our rough draft on the first graph that we do. So I'm going to do another graph over here on each of these problems for a rough draft. So as I do x is less than negative 3, I'm going to put between these two, that's a smaller number. And what I'm going to do for my rough draft, since I don't have numbers already put on there, is I'm just going to put the two numbers that we're dealing with, negative 3 and 7. And negative 3 is smaller, so I'll put it on the left. 7 is bigger, I put it on the right. Negative 3 is an open circle going to the left, where 7 is an open circle going to the right. And that looks like a normal graph if it was an OR graph. However, that does not look like an AND graph. AND graph, we want where both scenarios are true. Here, there is no place where both scenarios are true. A number cannot be less than negative 3 and greater than 7 at the same time. That's impossible for it to happen. It's one or the other. So when we go to graph here, we say, actually, we can't graph because this is really no solution. this is really, once again, no solution, because our solution for AND graphs is where both are true. For example, let's look back here. As I mentioned up here at the beginning of the AND section, I said when we're talking about x is greater than or equal to -2, we didn't continue on the arrow forever. We stopped once we hit 5 or less than 5 because we want it to be both scenarios being true. Same thing the other direction. For less than 5, we didn't continue going. We stopped when we hit -2 because we wanted it to be both scenarios at the same time, greater than or equal to -2 and less than 5. So the same thing's true here. We want both scenarios. There's nowhere where both scenarios exist, so we say it's no solution. Interval notation, there's no way to do the brackets and parentheses, so we can just do the 0 with a line through it, which is the empty set, or just nothing. I also mentioned how you can do like NA for not applicable, or you could do like none for interval notation, or you put a dash, or any of those things saying, hey, you can't do the interval notation because there's no interval for it to be true on. The next special case, once again, I'm going to encourage the use of a rough draft graph. It's kind of hard to say there. And I'm going to put the two numbers on that we're dealing with, 0 and 6, the smaller number on the right, the bigger on the left, so 0 and 6, and greater than or equal to 0. So I'm going to close dot to the right, and less than 6, so going to the left. Now, this is a very normal AND graph. We have them going toward each other, the two arrows going toward each other, two inequalities going toward each other, and so we just want the overlap. Where is the overlap true? Well, between the two. So we're going to graph it as if we normally would, where you do a closed circle at 0, an open circle at 6, and you connect the two, which once again is just a very normal AND graph. So even though it's in the special case section, we still have some normal ones here, so that way we can see the difference between the two a little more clearly. So the interval notation for this problem would be 0, 6, with 0 getting a bracket and 6 getting a parenthesis. Moving on to number 3, once again a rough draft graph being utilized. We have 5 and 8. 5 is smaller, 8 is bigger. K is greater than or less than or equal to 5 rather. So I'm going to do a closed circle to the left, and it's less than or equal to 8, which is a closed circle going left. Okay. So here, once again, for AND graphs, we want where both are true. Well, neither of them are true. Neither of them are talking about numbers greater than 8. Only one is true in this gap between 5 and 8, but both are true down here. If a number is less than 5, it's automatically less than 8 as well. So if it's true here, it's automatically true there. Meaning, as we're looking for our overlap, this part of the graph isn't useful for us at all because it's not actually part of our solution. The only part that is part of our solution are the numbers that are already less than or equal to 5. So for that, or actually I'll just leave that slash on, for when we do the actual graph, I'm just going to graph the 5 and to the left because those are the only parts that are actually part of the solution. It's the only thing where both inequalities are true at the same time. So as I do my interval notation, I go -infinity, 5 with the bracket. So these end up looking a lot more like the non-compound inequalities in this scenario. When it's an and they overlap, we take only the overlap. Number 4, once again, encouraging the use of a rough draft graph. -4 and 2 are the numbers we're comparing to, with -4 being smaller and 2 being bigger. And I'm going to do an open circle on -4 and go to the right, a closed circle on +2 and go to the right. So once again, we're only concerned with where they're both true. Neither are true when it's further negative than -4, less than -4. Only one is true between -4 and 2, and they're both true greater than or equal to 2. So if a number is greater than or equal to 2, it's automatically greater than -4 at the same time. So that's what we're concerned about here. So when we go to our graph, we're like, we don't need that left part, but we only need the part where it's greater than or equal to 2. So I'm going to graph that and graph only that, and my set notation will reflect that, 2, infinity. So those are the 4 scenarios you can encounter with AND inequalities. The first scenario ended up being no solution when they have no overlap. The second scenario was our normal solution where the overlap is just between the numbers. And the third and fourth scenarios were special cases as well, where the overlap is only on the left or the right rather than between both numbers and between the inequalities. So we end up just writing one inequality because the other one ends up just being unnecessary. Number 5 through 8 deal with or compound inequalities. Once again, I'm encouraging rough draft graphs here. So -8 is smaller than 1, so I'm going to put -8 on the left, 1 on the right. And less than -8, open circle to the left. Greater than 1, open circle to the right. And that looks like a normal OR graph, which it is, similar to how number 2 was a normal AND graph. Number 5 is a normal OR graph. So -8 to the left, 1 to the right, and we do our set notation, or interval notation like we did before, where we do the left part, -infinity, comma -8 with parentheses, union, and then the right part, 1 comma infinity with parentheses. So now 6, 7, 8 will be our 3 special cases scenarios for OR graphs. So on 6, once again, I'm encouraging a rough draft. -2 is smaller than 7. So -2 gets a closed circle, though, to the right, because it's greater than or equal to, where 7 gets an open circle to the right. Now, an OR graph, we want where at least one is true. This or that, okay? This or that. So, for example, you could come on Monday, or you can come Monday through Wednesday. And so a scenario there is you could pick a Monday through Wednesday, and that automatically includes Monday in the scenario. So we're saying we want a number that is greater than or equal to -2 or greater than 7. This is what we're talking about, is everywhere from here to the right. Meaning if we don't have this part graphed, the y is greater than 7, this arrow covers that anyway. Meaning it's very unnecessary to have this part. It's redundant. It's extra information that is not needed and makes it more cluttered. And so we don't write it. And we just do a closed circle at -2 and go to the right. Because once again, this is redundant for our OR graphs. So I like to think of it as or you want which one covers more, and you want the overlap between the two, or you want the one that covers less. It's more specific where or is less specific. So writing the interval notation for this is like our ones from 1.3, where we have -2 comma infinity, and -2 has a bracket. Number 5 here, as we do in my rough draft again, smaller numbers -9, bigger numbers 3. Graphing the one with -9 is less than or equal to -9, so it's a closed circle to the left. With +3, it's a closed circle to the left again. And just like on number 6, we want whichever one covers more area. And so this is redundant. This one covers more. The x is less than or equal to, n is less than or equal to -3. So we graph that and only that closed circle to the left. So or we want one, at least one is true, and we need where both are true, as I'm mentioning. So the interval notation would be -infinity, comma 3 with a bracket on 3 and a parenthesis on -infinity. And our last special case scenario, rough draft again, -1 and 1 with -1 being smaller, open circle for -1 going to the right, and an open circle for 1 going to the left. So here we notice that they go toward each other, which is very normal for an AND graph, but not for an OR graph at all. Well, something we can think of here is as these arrows come through, this arrow on the left is going to go forever to the right. And this arrow coming from 1 is going to go forever to the left. And we want where at least 1 is true. And at least 1 is true over here on this section of the graph. At least 1 is true between the two numbers. And at least one is true on the right side of the graph. So at least one of these inequalities is true everywhere. So we don't have redundancy necessarily, but we have everything covered. Meaning our solution is infinitely many solutions. Everything is either greater than -1 or less than 1. That'd be like saying hey, you can only ride this ride if you're taller than 5 foot or if you're 5 foot and below. And so if you're taller than 5 foot, congrats, you get to ride it. If you're shorter than 5 foot or 5 foot itself, you can also ride it, which just means that everyone can ride it, and you might as well not have the restriction. So instead of writing these inequalities and graphing it like this, we'll just show the whole thing works. And the interval notation would be negative infinity to infinity. It goes forever left to forever right, which once again is our IMS. So now let's practice these compound inequalities a bit. So we're going to solve, graph, and give our answer in interval notation. So some of these might be compound inequalities. Some of them might be regular. We're going to have to graph and see. So when you're not sure whether it might be a compound or not, I suggest doing a rough draft graph so that way you don't necessarily mess up your actual graph. Or if you're doing it in a pencil and you can erase, that's also an added benefit. So number 9, we have OR. We solve these separately like we were earlier. So adding 4 to both sides, and the left inequality gives me x is greater than 3. The other one I divide by negative 8, and I get x is greater than negative 6. So I have to flip my inequality after dividing by negative. So we're encountered with x is greater than 3, or x is greater than negative 6. As I go to graph this, and I do a rough draft, I notice negative 6, I notice 3, and I do open circles on each, and negative 6 goes to the right, but 3 also goes to the right. Special case, and with OR, we want whichever one covers more area, meaning this is redundant and unnecessary. So I'm just going to graph the negative 6 part, I'm just going to put an arrow to the right, and for interval notation, I will just say negative 6 comma infinity with parentheses on both. And when I circle my answer, I only circle that inequality as well. I don't even include the other inequality because it's redundant, absolutely unnecessary. Now, I do want to note a big hint for these, for these inequalities, is the directions for the symbols. So notice the special cases we had, which were 1, 3, 4, 6, 7, 8. These were all our special cases of inequalities, where 2 and 5 were not. Okay? One commonality between some of them, between the ones where we either just picked one side or the other side, like we did on 3, 4, 6, and 7, a commonality between those 4 is that the inequalities are both facing the same direction between the two. So anytime you have the inequalities facing the same direction, you're going to end up picking one of them rather than both of them. Whereas in our other two special cases, which are 1 and 8, as well as our two normal scenarios, 2 and 5, so once again, our special cases 1 and 8, as well as our normal scenarios 2 and 5, the inequalities are different directions. One's a less than, one's a greater than. Well, one's a less than or equal to, vice versa. Some form of less than and some form of greater than. And so when you have those, that's when you have to watch out for the no solution or IMS. A hint for that as well that you may or may not notice is that for the ands, if it's less than the smaller number and greater than the bigger number, you're not going to have overlap, because we can't be less than a smaller number and greater than a bigger number. Whereas ands typically are greater than the smaller, less than the bigger. And fives shows that ORs are typically less than a smaller, greater than a bigger, because they go out away from each other. And if you have greater than a smaller and less than a bigger, that's when we get the IMS. Now maybe you don't remember that last part that I mentioned as far as like how to differentiate the IMS and no solutions, but hopefully the part where we have and or inequalities having the same direction for the inequalities is a dead sign that we're going to have one of these special cases where it's one inequality only. Now I do want to say that's only when the inequality is solved. So let's say, for example, even though these were different directions to start, they were the same direction by the time we finished solving. Moving on to number 10, we have this and inequality here, so we solve them separately like we did before, and then we'll condense it perhaps, but I would check the rough draft first before condensing, because maybe you don't need to. So multiply both sides by 8 to undo the division. 8 and 8 reduce, and we get p is less than or equal to -1. So let me try that again, -8. On the other one, I subtract 9 from both sides, and I get p is greater than, my mind just blanked there, sorry, 6. It's a big old brain fart. So as I do a rough draft, I notice these are different directions, so it's not going to be a pick one. So it's either a normal and, or it's a no solution and. I do -8, close circle to the left. I do +6, open circle to the right. And I notice they don't overlap, so this is no solution. I don't have to bother condensing it because there's no solution. I don't have to bother graphing it because there's no solution. In the interval, we can just put the empty set or the slash or the dash, or the n/a, the none, whatever you want to say there, that is getting the point across that there is no solution for there to be an interval for. Moving on to number 11, another and one, not to be confused with the brand and one, old clothing brand there. So we subtract the 7 in this first one, we get r is less than 3. And the other one, we add 1 to both sides, we get -2r is greater than or equal to -2. Dividing by -2 gives us r is less than or equal to 1. We notice these are going the same direction. That's a dead giveaway. We're going to have to pick one of them. So let's figure out which one we're going to pick by doing the rough draft. So I'm going to put the smaller number on the left, which is 1, the bigger number on the right, which is 3, close circle for 1 going to the left, open circle for 3 going to the left. And once again for and, we want where they're both true. The only spot where they're both true is over here, meaning we can not worry about that other part. So as we do that, we graph by going to 1, close circle, and going to the left. And we only circle that inequality, not the other inequality. We don't have to worry about it. And for interval notation, we do -infinity, comma, 1 with the bracket around 1. Let's move on to number 12 here. On number 12, two separate inequalities. So let's go ahead and start working on this one. I noticed that they're both going the same direction, so that has some alarm bells going off. But let's just check to see if that persists when we solve these out. And so I'm going to multiply this left one by -2, or -2 over 1 on both sides. The -2 is reduced to 1 and 1, and we get a minus 4. Because we multiplied both sides by a negative, we do flip that inequality symbol, and we get -2 on the right-hand side. Adding 4 to both sides results in a is greater than, or excuse me, less than or equal to +2. Solve my other one, I'm going to add 1 to both sides, and I get a is greater than or equal to 6. And so now, as I notice, these graphs, the inequality symbols, are opposite each other, so that either means it's going to be IMS or it's going to be just a regular OR graph. So let's do a rough draft and check. The 2 would go to the left, the 6 goes to the right, and it is in fact just a normal graph, which is nice. So anytime it's less than the smaller and greater than the bigger for OR, that's normal. The opposite would be true for and ones to be normal. So I'm going to go ahead and make the closed circle at 2 on my actual graph and make my interval notation, so it's -infinity, comma 2 bracket, union, 6. Oh, my apologies. I keep writing 6 here, but that's incorrect. It's not 6 at all. It is 7. So I apologize to anyone who's confused about this, as I've been saying 6 and writing 6. It's been 7 this entire time. 7, 7, and then the orange here in the problem, 7. My apologies on that. So we have the bracket 7, comma infinity. And I'm going to go ahead and rewrite my inequality here, saying or a is greater than or equal to 7, and box that answer. Moving on to number 13, two inequalities. I notice these are going the same direction, so I do have some alarm bells going off that maybe we'll pick one or the other at the end of this, but let's go ahead and solve them once again, see if it persists. Because on the last problem, it changed and fixed itself to where they were going opposite directions again. So on this left one, I'm going to subtract 3 from both sides and get 5k is greater than 5. Then I'm going to divide by 5 and get k is greater than 1. My other inequality is subtract 8 from both sides and get 9k is greater than or equal to negative 81. Divide both sides by 9 and get k is greater than or equal to negative 9. So we do in fact have them both going the same direction. So a good thing those alarm bells were going off there. Let's do our rough draft. Negative 9 on the left, 1 on the right. And negative 9 is a closed circle going to the right. 1 is an open circle going to the right. Now, we mentioned how for and, we want where they both are true, where they overlap. So there's neither are true here, only one is true in the middle, but both are true over here. Those numbers are both greater than 1 and greater than or equal to negative 9. So realistically, we don't care about this graph on the left, but only the graph on the right. So as I do my final draft, I'm only going to include that one. And as I do my interval notation, I'm only going to use that one as well of k, I wrote a, k is greater than 1. Sorry, that's not interval notation. I got mixed up with set notation there for a second where I was about to do the such that and the braces. But for interval notation, we do 1 comma infinity with the parenthesis around the 1 and the infinity. And I'm going to circle only this one, but not the other because we didn't end up using it at all. It ended up being redundant. Or not redundant, but not part of our solution. 14 here. Work on solving this one by subtracting 1 on the left inequality. So I got negative 2y is greater than or equal to negative 18. Then I'm going to divide by negative 2 and get y is less than or equal to, flipping the inequality symbol as we divide both sides by a negative, 9. As I work on solving my other one, I'm going to add 5 to both sides and get 5y is less than or equal to negative 45. Then I'm going to work on dividing both sides by 5, and I get y is less than or equal to negative 9. So I notice here, they go the same direction. Alarm bells are going off in my head that we're only going to pick one or the other, so let's figure out which one we're going to pick. Negative 9 on the left, 9 on the right, both closed circles, and both arrows go to the left. Now, we said for and, we want where they overlap. However, for or, we want whichever one covers more area. So this one only covers a little bit, where less than negative 9, or less than or equal to negative 9, covers all of this. And so that's the one we want. So we're not concerned about this, only this inequality. So we reflect that in our graph and just graph the closed circle at 9, that was 7, and go to the left. And our interval notation reflects that as well, negative infinity, comma 9 with the bracket. And I only include that one for my box answer as well. Number 15 here, I'm going to work on the one on the left first by subtracting 6 from both sides and get 2x is greater than negative 10. Divide by 2, and x is greater than negative 5. Working on my other one, I subtract 5 and get 9x is less than or equal to 36. Then divide both sides by 9, and x is less than or equal to 4. So these do go different directions, but let's do a rough draft just in case there is something abnormal or special about this one. So negative 5 on the left, 4 on the right. Negative 5 would be an open circle going to the right, and 4 would be a closed circle going to the left. So this is an OR graph that goes toward each other as if an AND graph would. And so that's where we have infinitely many solutions. And once again, that's because we want where at least one is true, and at least one is true for every number. Any number would be less than negative 4, or less than or equal to 4, and greater than negative 5, or greater than negative 5. Let me try that again. Any number would be greater than negative 5, or less than or equal to 4. It's always possible it's going to be at least one of those. And so for our graph, we just do the entire line. And for interval notation, we do negative infinity, comma infinity, because it goes forever left and forever right. Let's work on number 16 here. On number 16, and inequality, or and compound inequality. Working on my left inequality first, I got 10v, subtracting the 4 gives me less than 40. Then I'm going to go ahead and divide by 10 and get v is less than 4. My other inequality, subtract 6 and get 3v is greater than negative 21. And dividing by 3 results in v is greater than negative 7. So even though these do go the opposite directions, I'm going to go ahead and do my rough draft though, just in case something is still amiss or up to something abnormal. Negative 7, 4, and negative 7 goes to the right, and 4 goes to the left, just like an AND graph should. So we go ahead and graph this normally. And our interval notation reflects that of negative 7, comma 4 with parentheses on each. And as we write our solution, we're going to write the smaller number, negative 7, v in the middle, 4 on the right, and either less than or equal to symbols between each as we look at these. So v and negative 7 just had a non-less than or equal to symbol, ignore the low power, and v is less than 4 just had to rig their symbol as well, not or equal to. So that would be our solution here. Moving on to number 17. Number 17, we have an OR inequality. And so working on the one on the left first, we'll subtract 1 on each side. 10n is greater than or equal to negative 60. And then we divide both sides by 10. And n is greater than or equal to negative 6. Solving the other one, I'm going to add 10 to both sides and get negative 9. N is less than 36. That negative stays with the 9n. Then I divide by negative 9, and n is greater than negative 4, flipping the inequality since we divided both sides by a negative. So these go the same direction, so I know I'm going to be picking one or the other. The question is, which one do I pick? So we do a rough draft. Smaller number on the left, bigger number on the right. N is greater than or equal to negative 6, that'd be a closed circle going to the right. And greater than 4, negative 4 is an open circle, also going to the right. And for OR, we want whichever one covers more area, which is certainly not this. Negative 6 and to the right covers more area. So we're going to do a closed circle at negative 6 and go to the right. Circle just that one, and our interval notation reflected as well by saying negative 6, comma infinity, with a bracket around negative 6 and a parentheses around infinity. Last but not least, number 18. Solving this and compound inequality, starting off with this inequality on the left here. You could start with this inequality, by the way. There's nothing wrong with that by any means. I just always go left to right. So I add 4 to both sides, and I get 6k is greater than or equal to negative 42. Dividing by 6 results with k being greater than or equal to negative 7. The other inequality, we subtract 5 and get k is less than or equal to negative 10. So let's go into a rough draft, even though these do go opposite directions, just to check what's going on here. Negative 10 is smaller, negative 7 is bigger, and less than or equal to negative 10 would be a closed circle going left. Ooh, this is looking weird, because ands are supposed to go together. And greater than or equal to negative 7 would be a closed circle going right. So these ands do not go together. There is no overlap here, which is what we look for with and compound inequalities. So this is no solution. There is no graph. And for interval notation, as I mentioned before, you can do like this 0 with a slash through it, which means the empty set or no answers. You could do like a slash or a dash. You could do NA, which means none available. You could just say none, and I'm good with any of those. Well, this wraps up section 1.4 talking about compound inequalities, including those special cases.